Okay, good morning, good afternoon, good evening, wherever you are watching this. So obviously it's about holistic exam A, clues obviously in the title, no surprise with that one. So rather than go through criteria, what I've done is take some comments from people that have come back from exams, etc., and they're just querying certain things. So I've made two lists here. List 1 is about site prep and list 2 is about the science. And there's a few bits I think that catch people out. So I kind of really want to just briefly skim over those two areas really, without going into too much depth, if I can point you in the right directions. So bearing in mind, holistic exam A is about site prep and science. They're the only two you've got. It's closed book, and it's 30 questions. That is it. Okay. So you could argue it's worse than B. I think they're both equally as difficult and as challenging. But to be fair, they should be, because that's what our trade will require. So I'll start going through the site prep stuff, and as I said to a few of you before, when you've watched these videos, if you make some notes as you go through it, as you're watching this, that's always only going to be useful, isn't it? And hopefully it'll answer a few of these questions that you might have. So we'd start with site prep then. So notchings of joists, etc. This seems to be a common theme in exam A and exam B, and to be honest, I understand why, because it makes sense to be in both. So it's 1/8 of the depth of the joist as much as you're going to notch. That's all you're allowed to do. So how do you work it out? Well, if you've got whatever the depth of the joist is, you divide it by 8. There's your answer. That is kind of it. It's as easy as that, and then you just pick the appropriate answer, don't you? And that's what it's easy. So 1/8 of the depth of the joist. Don't try and be clever to work it out as an eighth, etc. Just divide it by 8, and you'll get your answer. It's as simple as that one. Okay, some other things on there was something called a proprietary fitting. So proprietary fitting is a fitting that will connect one material to another, and it's just a common name that is given. Now we could refer to this as a lead lock, which would obviously suggest that it connects copper to lead. No surprising with the name. You can also get fittings though that will connect onto MDPE. So the way that you will tell is if you're looking at the fitting, and in the fitting if there's a rubber O-ring seal somewhere in there, that suggests it's going to be for plastic. And it wouldn't take too much to work out that plastic O-ring seals work on most plastic pipes and fittings, so it's quite straightforward, I believe, to be able to figure it out from whatever picture or diagram you've got. So that's what we mean by the word proprietary fitting, a fitting that will connect from one material to another. So again, be careful. Just a few questions I've had about certain screws, etc. So what screws do you use? Well, we use a lot of posi drive screws, and you get posis and you get Phillips. They look very similar, but there is a difference. So if you look at a posi drive screw, you've got the normal cross head, but you've also got markers that come off each corner that look like a star, and that would denote that it's a posi drive head. A Phillips is just a standard cross head with no markers either side. So if you want to look at a picture of one, all you've got to do is you can either use Google, you can use your books even, and you'll see the pictures between the two, and that's the difference there. What do we use the most? Well, we use posi drive the most. That's what we use. Also taking floorboards up, the equipment you're going to use. Well, the first thing to think of is PPE, so obviously goggles, ear defenders, etc. What tool would I use to remove floorboards? Well, you could have a floorboard saw, which is a manual saw, which looks slightly different from your normal wood saw. But most people use something called a circular saw, and that's what we'll tend to use for most things. So we'll work out what the depth of the floorboards are, and we use the circular saw to remove sections of floorboards, and we use a lot of those. Battery ones are the best ones, so but circular saw is another piece of kit that I'm going to use. So what else is on my list? So manufacturing instructions. A lot of people ask me about manufacturing instructions, and we covered this in exam B video, but I'll mention it again. What do the manufacturing instructions will tell you? 2 or 3 things. 1, how to install, so the installation instructions is key. It will tell you how to commission the system, so how to switch it on and get everything working properly. It will tell you about decommissioning, how to decommission it properly so nothing is damaged in the same time, and also it tells you about fault finding. So if there's a fault in there or a fault on the piece of kit you've installed, you can use that. So the manufacturing instructions, if you think about it, cover almost everything you're going to need for whatever you fit in. So if you are fitting a boiler, you're just going to follow the instructions, and that's as simple as that. It's like most things that we use, isn't it, as well? A few questions about testing of pipe work. So we've had the conversations about these, and we've gone through 806 and spoke to you about it. Now the first thing you do before you test is visually check everything, isn't it? And again, I've said this on exam B, so there is a theme with these, which is fine. There's nothing wrong with it, 'cause it actually makes sense if you look at how they've done the criteria. It's quite good. So you're going to do a visual inspection prior to switching on. You're going to make sure everything is tight, aren't you? That you've soldered everything, etc. So there's no good just switching something on and hoping for the best when you've not checked anything, because the likelihood of it leaking and causing a problem is probably high, isn't it? So think about those basic things that you've got there. Pipework going through walls. Someone asked me a very good question about this. Well, if you've got 15mm pipe going through a brick wall, what do you need to do? Well, it needs to be sleeved. Let me explain what the word sleeved means, I think, first, just in case you're not quite sure. When we sleeve pipework, we put smaller pipework inside bigger pipework, and the bigger pipework is the protection for the smaller pipework. So, for example, if I drilled a 22mm hole through a wall, I put some 22mm pipe through, and then I piped 15mm through that 22mm and off to outside or wherever it was going to. That's what sleeving is called. It's a way of protecting the copper, for example, against brickwork. Now you could argue, well, the sleeve you just said you're going to use is 22mm copper. Okay, it'll eat the copper a little bit, but it won't cause a damage on the sleeving, will it? Ideally, 22 plastic would be even better, wouldn't it? That would be the most appropriate thing, because mortar likes to attack copper. So that's why we sleeve things. You sleeve pipework, whether it's through timber walls, whatever it may be, you'd sleeve them anyway. But brickwork is the main one. So if you've got that strange sort of question, you think, sleeving, what's a sleeve? All it is a bigger hole, a bigger tube going through, and a smaller pipe running through the middle, and it's there to protect it from being corroded. It's as simple as that. And that's what sleeving is. If you look at gas pipes, for example, sleeving's taking place all the time because it's within the regulations. Water side, it's how it's policed, isn't it? I suppose is the real question. So if you were to look at a job and think, oh, is that sleeved or not? You should be able to see the sleeving, but in water, from a water point of view, you could cover it over, but things should be sleeved. So yeah, a bigger size is always the sleeving that's required. Right, I'm going to spend a couple of minutes on clips now. So some people are asking me about clipping distances again. Clipping distances we did in exam B, but we'll go through. So it's 1.2 and 1.8 for 15mm, and 1.8 and 2.4 for 22mm. That's horizontal and vertical. They go in that section. Okay. Now some clips you can and can't use. Let's look at some of those. What do we use the most? Well, we use something called standoff clips. The standoff clips will literally lift off away from the wall, and then the pipework is never touching the wall, which is ideal, isn't it? So if it's copper and it's going to be screwed onto brickwork, the clips are, the copper's not going to touch brickworks. For the previous thing I've just mentioned, it will corrode it, won't it? So stand-up clips are the best thing we use. You can, however, get a variety of different clips. So you can get Munson rings, you can get those, which are, again, very useful clips, not really used domestically, it's more sort of commercial, or if the person really wants those particular things, so you can get most Munson rings, they're available as well. Other things you can get which are very rare though are copper saddles. So it's a piece of copper that looks literally like a saddle. It's like literally a little wrap over clip made of copper. Would you use that on concrete, say brick, should I say, mortar? Answer's no, isn't it? Because I've just said, when you think about it logically, you can't put copper with mortar and brick, etc., because it corrodes it. So why would you use a copper saddle? You wouldn't. A copper saddle would be ideal in an airing cupboard. And they used to get them years and years ago, to be fair. But they'd be in an airing cupboard where it's screwed against some timbers, so timber's not going to rot the copper, etc., so it'd be fine. And what it allows the pipework to do is to be pushed back as far to the wall as possible to try and give you the maximum amount of room. So hopefully that makes sense there. Other things on the site prep stuff I think are pretty straightforward. In terms of fittings and kitting, things like that, I think you've been pretty okay with that so far. So we'll stop there with the site prep. Hopefully that gives you enough sort of info just to sort of reevaluate your notes, etc. Reevaluate your thought process a little bit when you're faced with some questions. Right, we'll move into science then, and as I notice on the science there from feedback and from criteria, there's quite a bit on electrical, so we'll spend a bit more time on that one just to make sure we're okay. Right, people have been asking about sort of temperature taking, and I think people get them. You're not getting yourselves confused. I think it's probably the wrong word to say. But I think people are forgetting a little bit of logic. So how do we, what do we measure temperature in? Well, we measure it in centigrade, don't we? We know that, and that's what we do. We measure everything in centigrades. We don't measure it in Fahrenheit. We can convert it, obviously, but we don't measure it in Fahrenheit. We never have done. And we don't measure something in Kelvin, because it's the more scientific way of measuring something. And it's called absolute zero is Kelvin. So if you're going to look at how things could be measured, it would be centigrade, wouldn't it? That's one thing we would do. If we're looking for something called absolute zero, that's Kelvin. That's what we call a Kelvin scale. but as a plumber working on the tool, we wouldn't measure it in Kelvin, if that makes sense. So you've got to look at what the question's asking you in terms of temperature taking. I don't think it would be too challenging, if I'm at all honest, if you just take your time to read whatever the question may be and just think about it logically from that point of view. Okay, so just be careful with those sort of questions. Right, earth cables, etc. Right, so it talks about some types of earth cables. So we've looked at TNCS and TNCS, etc., etc. 6mm is the earth cable that's going to be used. Now, some documents say 10mm, so you've got to be a bit careful, but 6mm is what we're going to use for that. If we're going to remove a section of pipe work, we're going to use something called temporary continuity earth clamps, and that's what we're going to use. And most of you will have seen them and used them now in the workshop, obviously ages ago, when we were removing the central heating pump, and it's part of one of your assignments to do that, and that's what we would do. In terms of measuring different things, so if we're measuring what's coming into an electrical system for doing some fault finding, I'd use something called a multimeter. And the multimeter will help to find out if there's current there, yes or no. And I can change the setting on it to almost determine how I'd like to measure whatever I'm looking for. And that's what I would use there. Some people use something called a volt stick. You can use volt sticks. Volt sticks are very useful, but the most accurate way is using a multimeter. And the multimeter, you press your different probes into earth, live, neutral, and all variety of combinations to make sure everything's completely safely switched off and isolated. And that's your safe isolation procedure. It's part of it. So one part is turning off the consumer unit, checking the supply, lock it off, retain fuses, etc. And you would follow that sequence, and that's what you'd need to do with all of those as well. If we're going to measure resistance, we measure it in ohms. So that's how it's measured. So we did a lot of work on VIR, didn't we, which is the Ohm's law. It's the VIR triangle. And it can work out your volts, can't it, your amps and resistance, and it can work those three things out. So if you're using the VIR triangle, you take one away, you either divide or times depending on which way on the triangle you're going to go. And that's a pretty straightforward one to do. So if you measure resistance in ohms, so if you're not having a calculation to do, that's what you would certainly do. When you're measuring power, we're measuring wattage, aren't we? Because that's what we need to know. So for example, things that we use are in kilowatts rather than watts. So, for example, a 3 kilowatt immersion heater, and that's the sort of way we'd measure it, isn't it? Because that's the power output that we've got, and that's the way that we'd use it. The amps there is a form of protection of some description, isn't it? So you might have a 3 amp fuse, you might have a 13 amp fuse. You could be working out the amp size on a consumer unit, for example. We did the work on the electric shower where we worked out we needed a 40 odd plus amp, didn't we, on the consumer unit, and that's how we calculate it. So just think of the VIR and spend the time looking at the VIR. You've all got the science chapter that I've given you, so and as you know, it's freely downloadable anyway to anybody. So it's worth looking at that and just going through that. And we worked through all of those equations, didn't we, and did our own sets as well on top. So we should be reasonably okay with that. The last one really to touch on is something to do with sort of the gravity, and then people have sort of struggled with the gravity question. So it's 9.81. That's the gravity pull on Earth. In the Moon would be 1.6, which obviously if something's heavy here would be a lot lighter on the Moon. Quite straightforward. So whatever you're looking at what it will be in terms of being pulled down. You would times whatever the figure is. Let's say 7 meters, for example. You times it by 9.81, and that will give you the required answer. And that's what we'd need to know. You're thinking about pressure as well, and those different pressures you've got. So you've got bar pressure, that's what we measure most things in, don't we? We measure it all in bars. You've got kilopascals as well, which could be used, I guess, if you really wanted to. And in your books there's a conversion table, so you can kind of work your way across it quite comfortably, which I don't think is too difficult to figure out if you just look at the conversion going across. So for 1 metre head of water would give you 0.1 bar. They're quite easy, I think, to pre-calculate as well. So that's the way that you need to start to look at it and think how you're going to look at it. Yeah, so 1 bar pressure is 100 kPa. There you go. It's quite simple and logical and straightforward. So 0.1 bar would be 10 kPa, so on and so forth. Okay, so just have a look at your table to make sure you're fine with those, because you'll need those sort of conversions to work your way across. Okay, there's not really much else to pretty much say in terms of those two units. Although my only suggestion is this, and I've said this to most people: when you're doing the questions, just take the time. Now with us, we have a time limit on ours anyway. You've got 30 questions, which gives you an hour, which is 2 minutes per question. You want to at least be in there for 45 minutes, and I don't think that's unreasonable to work it out. So take your time when you do to it. Read the question 2 or 3 times. Don't not read it and just go, well, I've done this once before, I think I know everything, when you're probably going to more than likely change your answers you got last time, which were correct. Some people are doing that. They're going to they're second guessing themselves and getting it still wrong, which is crazy. You just take your time in there and do what you need to do. Use the revision software I've given you, so I will be sending out some more codes shortly, so you know what the codes are for. You can do your online revision with that as well. Okay. Use both the videos. Like I say, I don't do them for fun. I don't do them for subscribers. I don't do them for anything else apart from you guys. I'm not interested in doing anything like that. So if the videos do help, make some notes with it, and you know that should help you with some of the criteria you've got. But I just didn't want to do the criteria this time because it took so long to do, and I don't think that many people stayed watching it till the end, which is fine. It doesn't matter, but I just don't think you've got the full amount that you wanted to. So I wanted to keep this one a bit more shorter where possible. Right, well, I hope you enjoy. I'm doing this on a bank holiday Monday, so if you are watching it today, I hope you've enjoyed the day. And if you're watching it during the week, I hope you did have a good bank holiday Monday. Okay, look forward to seeing you all shortly.